Today we will be reviewing the two main methods. Of graphing: slope-intercept form and standard form. Slope-intercept form uses the equation y equals mx plus b. Standard form uses the equation axy plus bx equals c. To use slope-intercept form, you need to understand the components of the formula. For the equation y equals mx plus b, the m stands for slope. Slope is the ratio of the vertical change, the rise, the y values, which is why I purposefully misspelled the word rise to help you remember that the y's go on top, and on the bottom is the horizontal change, the x's, or the run. The b value is your y-intercept. This is where you will always begin your graphing. Y-intercept is the ordered pair where the graph crosses the y-axis. Come on, get out of the way. When you start your graph, find the similarities between the equation and your equation that you have to graph. The -1 is in the same position as the b, so that's going to be your y-intercept. The m here is in the same position as the 2, which is going to be your slope, and we need it as a fraction, so 2 over 1. When you begin graphing, start on the y-axis, which we said is the -1 on the y-axis. From here, you're going to count your slope, 2 over 1. You're rising a +2, and you're running a +2, which is the direction right, going to the right. Up 2, right 1, up 2, right 1. You can go the opposite direction if you choose. Go back to your y-intercept, down 2 to the left 1. And I like to exhaust the space that I have using a straight edge. Connect all those beautiful little dots and arrows on both ends. There's your line. The other method is using standard form, which I like to call the cover-up method. Standard form, the equation needs to be in the order of ax plus by equals c. When the equation is in this order, you're able to find the y-intercept, which always has a 0 in the x and a number in the y, and you're able to locate the x-intercept, which is an x or a number in place of the x value and a 0 in place of the y, without too much work. I like using the table that I have drawn just below because it allows me to organize my x and y intercepts. I'm used to using a table from when I first started graphing, so it feels comfortable for me. What this method entails is that you need to place a 0 in the x position. So I'm going to put a 0 here. 4 times 0 is 0. So it essentially gets covered up. Which leaves me with the equation -9 equals 18. -9y equals 18. To get the y by itself, we'll divide both sides by -9 and -9, which means y equals -2. In your chart, you had put in a 0 for the x, and you got out that a y equaled 2. I go ahead and graph that. 0 on the x, +2 on the y. Then I go back for the other values. Erase that. In this particular case, I need to place the 0 in the y value. So if I were to put a 0 here, -9 times 0 is 0. It gets covered up. Leaving me with the equation 4x equals -18. To get the x by itself, divide by 4 and divide by 4. You may need a calculator, but x equals -4.5. What that means is that when you put a 0 here in place of the y, which I have written in the y column, your x equaled -4.5, so it gets placed in the x column. And I'm going to plot that point as well. 0 on the y, but I'm at -4.5 is halfway in between the 4 and the 5, and connecting those 2 points with a line that has arrows on both ends. Again, you can choose either method to graph. When things are presented in slope-intercept form, graph in slope-intercept form. When they're presented in standard form, graph in standard form. Not all of you like both methods, so I have a couple reminders for you. When you are solving for y, meaning if you prefer slope-intercept form, which is fine, you need to make sure it's always in y equals mx plus b. The two examples down here on the page aren't. First thing you need to do would be to move the x term by adding or subtracting. The x term is here. You don't want to move the 3 from the x. You want to take the whole 3x term and move it over with the 12. And because it's a positive, you're going to, it's a positive 3x, you're going to move the whole thing over by subtraction. So minus 3x, minus 3x. And you're left with, I have it typed in over here, 4y equals -3x plus 12. And I put the -3x so that it corresponds to the mx in the equation. Get the 4 to the other side by division. Divide everything, and you will be left with the equation y equals -3/4 x plus 3. Keep the fractions if they don't reduce, and reduce them where you can. If you want to graph this, you will start by graphing the positive 3. 1, 2, 3 on the y-axis, and from here I'm going to count my slope down 1, 2, 3, positive 1, 2, 3, 4. Can't really go much higher. My other point would be someplace up here. I'm not going to worry about going off the chart or off the graph paper. Connect. Oopsies. Connect those two, and then I'll put arrows on both ends. If you prefer using standard form, again, for the second equation, you need to get the y value by itself. The x term has already been moved, leaving only the y. So I'm going to move the 5 to the other side by division, because the 5 and the y are held together by multiplication. Leaves me with y equals 3/5 x minus 2. If I want to graph this equation, and I'm going to go ahead and do it in blue, I would graph the -2, and from here it will go up 1, 2, 3, positive 1, 2, 3, 4, 5. And I will make that line blue as well. With arrows on both ends. For sake of time in your video, I'm not going to worry too much about getting an equation into standard form, but if you'd like to see that, just ask. One last thing, and it's review from Algebra 1. Equations of horizontal and vertical lines. Horizontal lines follow the horizon. This is the horizontal line. I made it in red. Horizontal lines go through the y-axis, so their y equals whatever number they're going through. Vertical lines go up and down. Here's the vertical line. I made it in green. Vertical lines are always x equals a number, so x equal whatever x value they're going through.